based on linear systems, okay? And then we extend it to more than just linear systems. So on Thursday, we talked about two lines intersecting or potentially not intersecting. But then I also gave you problems that had a parabola and a line. And we had to find when those intersected the two times, okay? We'll eventually work our way into inequalities, systems of inequalities. We'll work our way into something called linear programming. And then what feels random but not completely random, something called partial fraction decomposition. It's a lot of syllables, but it's not as scary as it sounds, okay? So we only have, 6 sections, and really we kind of skipped over one of them, okay? So on Thursday, the worksheet that I gave you sort of covered 7.1, okay? We're going to now jump to 7.3. Tomorrow, we're going to push them both together and talk about the application problems for both of them. So before I start getting into this lesson, I do want to warn you, I am not going to be here tomorrow in the morning. I'll be here in the afternoon if any of you need me, but I'm not here in the morning. And so Emma is going to connect her phone to my projector and play the video from her phone. If that happens not to work, then I need somebody to help her or use their phone to do it. But I'm going to post a video online, and she's going to play it, and you're still going to get the notes tomorrow. Okay? Does that make sense? Okay. Whatever time is left after notes, you can work on your homework assignment, but that's going to be happening tomorrow. Okay? So today I want to talk about 3 variable systems of equations. Okay? When we step it up and we have 3 variables, we are in 3 space. So if I have a linear equation, what does that represent? It's no longer a line. I'll give you that. In 3 dimensions, our linear equation now represents what? It is a plane. So on number 7 and 8, I gave you 3 planes, and I'm asking you for where 3 planes intersect. Well, how could that happen? They could all intersect at one point. Don't try to draw these and write them down. It won't go well for you. Okay? They could intersect at one point. They could intersect in a line, right, where they share a lot of points in common. Okay? They could intersect simultaneously and be the same plane, just like we saw with 2 lines being the same in number 4. Right? Number 4 was infinite solutions. Okay? So these both are infinite solutions. This one is infinite solutions. No other way to put it. This one is infinite solutions, but we can actually model what that line is, and that's something that we are going to do today. Okay? Or what would our third option be? No solution. And there's 2 different ways this could happen. They could be intersecting, but not all 3 at the same time, so they don't necessarily have to be parallel. But they could be parallel planes and not intersect at all. Okay? So that is what's happening, all right? We probably won't look at a no solution problem in class, but what I do want to look at are these 2 cases today. Okay, so let's go to number 8. If you've done number 8, you can choose to redo it, all right? If you haven't done number 8, you're doing this along with us. If you did number 8 a different way than we're about to do number 8, that is not a problem. Okay. So here is our equation in number 8. Okay. Our goal from this, and I know some of you are really trying to reach back there and remember what you should do. Okay. Are you really good at solving 2 equations with 2 unknowns? Like number 1 and 2. Are you really good at that? You've been doing that since Algebra 1, right? And that was 4 years ago. Okay? You've been doing those for 4 years. So if we can get this into 2 equations to solve with 2 unknowns, Then we can worry about the third variable at the end. So what I want you to do is we are going to choose a variable to eliminate twice. Okay, so look up there. And there's no right or wrong answer, but of the three variables, if we have to use all three equations at some point, which variable may be the easiest to use elimination with? I hear Y, I hear Z. Z is nice because these two are the same. Y is nice because we have a -1y, and it would be easy to multiply things to without having to multiply the other one. Okay? Doesn't matter which one you choose. Let's maybe take a class vote. We're going to choose either Y or Z. How many of you would like to choose Y? How many of you would like to choose Z? Okay, let's choose Z. So let's first talk about what do you think? The second and the third? Okay. So if we take our our second equation and multiply it by -1, then our z's would be opposite. So I have -5x plus 2y minus 3z equals 0. That's our second equation multiplied by 1. Okay. And our third equation is 7x minus y plus 3z equals 0. Okay. And just so you can kind of follow along, I'm taking equation 2 and I'm multiplying it by -1 and adding it to equation number 3. Just so you know what I'm doing, okay? All right. So what happens? We made the z's opposite, so those go away, and we're left with 2x plus y equals 0. Raise my hand. Okay. So now we have an equation with two variables. We need to do that one more time, so we have a second equation with two variables. Okay? Any suggestions on which two we should choose? There's not a wrong answer. We've already chosen 2 and 3 to pair together. What's another pair we could work with? 1 and 2 would be great. And if I want the z's to be opposite in 1 and 2, well then I would have to multiply our first one by 3 and our second one by -5. Okay, so equation 1 we multiplied by 3. Equation 2 we multiplied by -5, and we're adding them together. Okay. All right, so what happens? Our z, does everybody agree with my multiplication of the 3 and the -5? Okay. What happens? When we add our x column, what do we get? -16x. Here we would get -5y equals 3. All right. Now this was our goal. We wanted to do elimination twice on the same variable so that now we have two equations and two unknowns. Okay? So now I have two equations with x and y. Okay? I think this is set up really nice for elimination, don't you? Okay? If we take these two equations right here, I can take negative 16x minus 5y equals 3. And what would I need to multiply this guy by in order to get, let's just say our x's to be opposite?
8.
Okay. So I can multiply this guy by 8 so that we have 16x plus 8y equals 0. Okay. We're just doing elimination on a two-variable system. Okay. So our x's cancel out and we're left with 3y equals 3, hey, which means y equals 1. So now we kind of have to go back step by step, okay? We are working with two variables and two unknowns. So let's stay there. We know one of the variables. Let's figure out the second. Well, we know from this equation over here that 2x plus y equals 0. Well, if we solve for x, that means x is negative 1/2. Now we need to go back one more level, okay? We solved our two variables. Now we need to go back up to one of the original equations and solve for z. So we know from the third equation that we have 7x minus y plus 3z equals 0. So 3z equals 9/2, which means z equals 3/2. So what we have x is negative 1/2, y is 1, z is 3/2. I do want an ordered triple, that's what it's called, for the coordinate in which these intersect. Just like before, we can check our answer. We can plug negative 1, 1/2, 3/2 into each x, y, z for the three equations and make sure when we plug them in, the first one equals 1. When we plug it in, the second one equals 0. When we plug it in, the third one equals 0. All right, I'm going to give you 5 minutes to try this one together at your table. Okay? I will tell you this one does have very nice answers. Okay? And by nice, I mean they are integers, positive integers. Okay? You can talk to each other. It's really okay. You did what I did? Yeah. Pretty exciting. Well, 3 plus 2 is 5.
I was wondering what it was. That's kind of
Yeah.
like they just have me go to
Yeah. Yeah. So this would be a 4. 6 and 2 or 11. That one. What are you eliminating? Okay. So wouldn't that be a negative 3?
Wait, this one I thought it was positive 3 because I was multiplying by -2. Or by -2.
But like when you add these together, negative 2y plus negative y would be negative 3y. Oh, over here. How'd you get z plus negative 3? Well, you would have to add 3y. It would be negative 9 plus 3y. Then you would have to divide by 2. Does that make sense?
Mm-hmm.
Okay, that's okay. Okay, we should be getting the answer of 1, 2, 3. Okay, we should be getting 1, 2, 3. Okay, what I would like to do now, let's check it. If you are getting 1, 2, 3, let's check. 1 plus 2 plus 3 equals 6. 2 times 1 minus 2 plus 3 equals 3. 3 times 1 plus 2 minus 3 equals 2. Okay? Works out pretty nice for us. So, what we are going to do now, we're going to do one more example so I can show you what happens when we have that infinite solutions case where they're intersecting in a line. Okay, so go ahead and write down this problem for me. Okay, so write it down, but don't do anything quite yet for me, okay? Okay, now, this is similar to number 7 from your homework, right? In the fact and how it's set up. You have one equation that only has 2 variables, right? In equation number 2, y is already gone. So if I'm going to eliminate a variable, which one would be a good one to choose? Y, because half of it's already done for us, okay? Y is already eliminated here, okay? So what we can do is we can take our first equation and multiply it by -3. And combine it with our third equation. Okay. We get -8x minus 4z equals -20. Okay. So we have this equation underlined in red and this equation underlined in red. These now are our 2 variable system. These are our 2 variable equations, right? Now we need to choose to solve for either x or z. Okay. Do you want to do that by elimination? Okay. So let's take this equation here. We have -8x minus 4z equals -20, right? If we want to eliminate z, Nathan, what would we need to multiply this equation by right here?
-2. Oh wait, it's just 2.
Just 2. Okay. And if we multiply that second equation by 2, we get 8x plus 4z equals 20. What happens?
They all cancel.
Okay. Now, just like you did in your homework on Thursday, if you get to the point where you get 0 equals 0, well, how often is 0 equal to 0?
Pretty often.
All the time, right? This is a case where we have infinite solutions. Okay. Now, let's go back to what we talked about at the very beginning of class. There's 2 different ways we can have infinite solutions. We could have all the same plane, or we could have 3 planes intersecting in a line. Okay? How do we know which one is which? Well, if we had the same plane, we would have gotten 0 equals 0 in the very beginning. Okay? Up here, we would have gotten 0 equals 0. But since we got down to the 2 equations with 2 variables to 0 equals 0, then I know we have a line that is the same. Okay? Now, have you ever written the equation of a line in 3 dimensions? No, there's no such thing as 3-dimensional slope. Okay? Rise over run over, how would you even write that? Okay? Well, we don't. Okay? So we are going to describe it in a way that we have slope, but we're not writing 3-dimensional slope. Okay? So what you're going to do when you get to this point right here for infinite solutions, you're going to pick one of these variables. Okay? One of your 2 variables. In this case, it's not right or wrong. You could pick one or the other. But you're going to choose one of these 2 variables, and you're going to say that variable equals a. And what we are going to do, we are going to express our answer in terms of a, to where we can plug in any number for a and get a coordinate on this line. Okay? We can't write the equation of a line, but we can write a coordinate that we can plug into to get coordinates from our line. Okay? Well, if z equals a, okay, we know that we have the equation 4x plus 2z equals 10. That was one of our 2 variable equations, right? Well, z equals a. So I need to come back in here and write in a for z instead of z. Okay, so now we need to solve for x. So we have 4x equals negative, what is this? 10 minus 2a. If we divide both sides by 4, then we get x equals 5/2 minus 1/2 a. We're doing the same thing that we did with numbers, except we just don't have. Once we get 2 variables, where do we go back to get the 3rd variable? Okay, we have to go back to the very beginning. When we're dealing with 2 variables, we can stick to our 2 variable equations. Now that we have those 2, we need to go back to the beginning and pick one of these. If we need to solve for y, which one of those 3 would be the best to choose? The first one, because y doesn't have a coefficient. It has a coefficient of 1. Okay? So now we can take these 2 and we can plug it in for y, or to solve for y. So we have 2x plus y minus 3z equals 4. But notice, instead of writing x, I plugged in what x equals, and instead of writing z, I plugged in what z equals. And now it's just a matter of combining like terms and getting y by itself. Okay, so if we distribute this through, we have 5 minus a plus y minus 3a equals 4. So what we have 5 minus 4a plus y equals 4. So y would equal, if we subtract the 5 over negative 1, if we add over the 4a plus 4a. So you would give me the ordered triple of 5 halves minus 1 half a, comma, negative 1 plus 4a, comma, a. Okay. What questions do you need to ask me about this? Joe.
I don't really get this up to for A.
Okay, so essentially, we need to describe our infinite solutions. Okay? But we're in 3 dimensions. We can't really write the equation of a line in 3 dimensions. So if we can write an expression for our coordinate to where we can find coordinates on that line, then that's just as good. Okay? We wouldn't do this in 2 dimensions, but it's our only option in 3 dimensions. So if you look at my final answer, I'll go back to the A, but if you look at our final answer, we can plug a number in for A and get a coordinate. We can plug a different number in for A and get a coordinate, and all those coordinates lie on a line. Okay? So what we do is when we get the infinite solutions, you're going to pick one of these 2 variables and just say that it equals A. And then we keep plugging that in so we can get the other variables in terms of A. And that's our way of writing the line without having to do 3-dimensional slope. Okay? It's going to take some getting used to. It's kind of strange, I know. But this is something that I need you to practice. Okay? This is probably the only thing that is different than what you talked about last year in Algebra 2 or Algebra 3, wherever you came from. Okay? So this is something that I need you to work on. Okay? Your homework assignment is 7 problems, but I don't think that they're all 3 variables. Okay? If you didn't finish number 5 and 6 on your green sheet, that's something you're probably going to want to do not only before the test, but probably before Friday's quiz. Okay? You will have some of these on your homework. Now, one thing I do want to point out, what if you chose x equals a? Is your answer going to look like this? It will not. It will look different. So if you get an answer and you chose a different variable to make a, then your answer might not look like the books. If they chose z to be a and you chose x to be a, they're not going to look the same, and that is okay. All right? If I give you one of these questions on like a quiz, I will have to do it 3 different ways so I can grade your answers. Okay? Don't worry about that.